Hello people! Welcome back to the Python programming tutorial. Today, we are going to have a look at classes and objects. We are also going to gain an understanding of object-oriented programming. By the end of this tutorial, you will understand the way to write easily maintainable and modularized code. Let's jump right in. We know that Python supports a lot of programming paradigms. Python supports functional programming, and we learnt about functions in an earlier session. Python also supports imperative, procedural, declarative, and parallel programming. Imperative programming is providing instructions in sequence. It focuses on how the result should be achieved. Declarative programming is the polar opposite of imperative programming. It focuses on what the result should be, rather than how the result is achieved. SQL is a good example. Using libraries like SQLite and SQL Alchemy, we can work with declarative programming. Parallel programming is made possible with the help of libraries like multiprocessing. If your machine has more than one core, Python can make the code run faster by distributing the workload across the cores. Procedural programming is a mix of functional and imperative programming. Here, we define a set of functions and execute them in the order we want. Now that we have an idea of the different programming paradigms, let us look at the most important one: object-oriented programming. This is the most commonly adopted programming paradigm by the developers. It gives great flexibility. The code is modularized. Hence the maintenance and debugging the code becomes easier. Object-oriented programming system, or OOPS, is achieved through two simple concepts. They are classes and objects. In Python, everything is considered an object. A string is an object. An integer is an object. A list is an object. In other words, anything that contains a value and has some methods associated with it is called an object. To understand more, we need to understand about classes. A class is a blueprint for creating objects. It defines attributes and methods that the objects created from the class will have. Attributes of a class are the variables that belong to the class. Methods are functions defined in the class. The first parameter of a method is always self, which is the indication that the function is a part of that class. Let us look at a quick example. Here we have a class called human. It has two methods, init and introduce. The init method is also called constructor. It is the method that gets called when an instance of the class is created. All the attributes of the class are defined within the constructor method. It is not advised to define the attributes of the class outside of the constructor. We can make anything an attribute of the class by assigning it to self, as in line 3. Introduce is the other method. It prints an introduction of the human being. Since we have made name as an attribute of the class, it can be used in any method of that class. It is to be noted that all the methods of the class take in self as the first parameter, including the init method. Conventionally, the classes are named in Pascal case, and the methods are named in Snake case. What are the advantages of OOPS? Let us look at a couple scenarios to understand this. If you are developing a large application, it would be impossible to keep all the code in a single script. But if the code is organized into classes, it can be kept in individual scripts and can be imported into other scripts. Since the code is organized into classes, it becomes easily maintainable. When you are debugging, you can isolate the bug to a particular class, and you can focus on that particular class, instead of going through the entirety of the code. We can design the application as a union of component parts. This is called modularity. Since the code is contained in classes, it is possible to reuse the code, as required. Also, we can restrict the access to the attributes and methods of the class. There are some properties of classes that help in increasing the reusability of the code and enhancing security, in addition to modularity and maintainability. Let us look at them one by one. Encapsulation refers to the bundling of attributes and the methods into a single unit. It also restricts access to certain details of an object's implementation, making the object's data safe from unintended modification. In Python, you can restrict access using private and public access modifiers. Public members are accessible from outside the class. Private members are prefixed with a double underscore, indicating that they should not be accessed directly from outside the class. In this example, we have a class called dog, which we instantiate with name crypto and age 10. Age is assigned to a private attribute. We do not provide direct access to it, but rather through public methods. We can set the age and get the age. But, if we try to access the double underscore age attribute, we get an attribute error. This means that private attributes cannot be accessed directly from outside the class. Inheritance allows one child class to inherit attributes and methods from a parent class. The child class is also called subclass, and the parent class is also called superclass. This promotes code reusability and establishes a relationship between classes. A child class can override methods of its parent class to provide specialized behavior. We have two classes here: Dog and Siberian Husky. Dog has two attributes and two methods. The class Siberian Husky inherits from the parent class Dog and makes some modifications. In line number 9, we can find the syntax to inherit from the parent class Dog. In the init method, we call super.init, which inherits the attributes of the parent class. In line number 12, we do an attribute override. In line numbers 14 and 15, we do a method override. Through inheritance, we can make a copy of the class, and by overriding the inherited methods and attributes, we can impart specialized behavior to the child class. Polymorphism literally means many forms. A method in the parent class can be redefined in the child class, giving it a new form. So, polymorphism relies heavily on inheritance. In this example, we have a parent class called shape. It has one method, calculate area. The classes rectangle and circle inherit from the parent class shape. They take in different parameters, but the objective is the same, calculating the area. Now let us try and understand polymorphism in this example. When we look at the method calculate area in the three classes, we could see that they are of different forms. In the parent class shape, it is an abstract method. An abstract method is a placeholder, intended to be redefined in the child classes. In the rectangle class, it takes in width and height and calculates the area. In the circle class, it takes in radius and calculates the area accordingly. The same method takes three different forms here. This is the simple example of polymorphism. By using polymorphism, we can write more generalized code that works with objects of different types. This reduces the need to write repetitive code and allows a single function or method to handle various object types. When using polymorphism, code becomes easier to maintain and extend. Changes made to base classes propagate to all derived classes, making the code easier to modify without breaking existing functionality. Abstraction refers to hiding complex implementation details and showing only the necessary features of an object. The goal is to focus on what an object does, rather than how it does it. In Python, abstraction can be achieved using abstract classes and abstract methods. Let us look at the same example to understand abstraction. The class shape has an abstract method called calculate area. Since there is an abstract method in the class shape, it becomes an abstract class. It cannot be instantiated directly. It can only serve as a template to its child classes. We create abstract methods using the abstract method decorator. A decorator is a string placed over the method name, prefixed with the @ symbol. In summary, abstract classes and abstract methods help in defining a template class that showcases the intent of the class rather than the complex implementation of it. In summary, encapsulation refers to the methods and attributes of the class working as a single unit. It also imparts access control and enhances security. Inheritance helps in code reusability by extending or modifying the functionality of the parent class. Polymorphism is the property by which the same method can have different implementations in multiple related classes. It relies on inheritance. With the help of abstraction, complex implementation of the class can be hidden, and only the high-level functionality of the class can be showcased. With the help of all these properties, classes help in increasing the modularity, maintainability, security, and reusability of the code. For more Python tutorials, like, share, and subscribe. Don't forget to hit that bell icon. I'll meet you again with another informative video. Until next time, happy learning!